The Sun is an incredibly bright and powerful star. As I mentioned in my Dyson Sphere video, it shines with the energy of 1 trillion nuclear bombs per second. It does this with nuclear fusion, and today scientists are trying to find out how to do it artificially. As many of my viewers might know, the Sun is not a solid, liquid or gas, but plasma, which is a goo-like substance where atoms are so hot and dense that they fall apart. But because of the Sun's incredible mass, it smashes the atoms back together to create energy. Since the nuclei are positively charged, they repel each other. This means that they have to be going extremely fast. And because of physics, extremely fast means extremely hot. For this reason, plasmas can easily reach temperatures of up to 1,000,000 degrees Celsius. So how on earth are we supposed to repeat this process? There are multiple designs for what a nuclear fusion reactor should look like and how it would work. But I've chosen the most commonly used system for this video. This involves a toroidal structure, which allows the plasma to swirl around and around to allow it to accelerate.
Good. So if we go for it, how would it work?
One big question that people often ask is, what fuel should we use for nuclear fusion? There are 3 possible alternatives. The first one is a form of hydrogen called tritium. The second one is called helium-3. And the third one is also an isotope of hydrogen called deuterium. Let's start with tritium, which is a radioactive form of hydrogen. It is most commonly used in harmless amounts to make watches glow in the dark. Unfortunately, since it's very not dense, using large amounts of it can easily leak out and pollute the environment. So it's best to stay away from tritium. Now let's talk about helium-3. Unfortunately, it is very, very rare on Earth. And here's where the Moon could provide an answer. In the future, we could start mining helium-3 from the Moon, and could affordably send it back to Earth. Another reason to start a moon base if you weren't convinced already. And finally, deuterium might be the best fuel, since 1 gram of deuterium can release a total energy of 845 billion joules of energy. This can power 21 houses for an entire year. This is comparable to 88 tons of coal, or 0.7 kilometers squared of solar panels. It's also easy to harvest since we can just split it from water. So if fusion is so great, why aren't we using it every day? One reason is because people are afraid of creating nuclear disasters, but this comes to an exception. If the reactor were to breach, the plasma would just leak out and expand and then go away. Also, just because it has the word nuclear in it doesn't mean it releases a lot of radiation. So if it were in a concrete building, radiation poisoning is not a concern. But the other 2 reasons are much worse. The first one is that it costs billions to build a nuclear reactor. And the second one is that it takes more energy to get the reaction started than it actually produces. So maybe nuclear fusion is ahead of its time and we should try in some 50 years or so. Thank you for watching this video. I hope you like, subscribe and comment on this video, or even share it with a friend. This has been Head for Science.